Hi everyone, this is the notes for lesson 1.3. So a lot of what we're learning in this lesson is a review from the trig that you learned in geometry. But the difference is that now we're going to put our triangles on the coordinate plane. So when we define them, we're going to talk about them as x and y, but you can still think of them as opposite, adjacent, and hypotenuse, which is what we'll talk about most of the time. So in geometry, you had sine, cosine, and tangent, but now we have three extra ones, and those are the reciprocal functions of sine, cosine, and tangent. So sine and cosecant are reciprocal functions, cosine and secant, and then tangent and cotangent. So I remember them because, or which ones are partners, because they sine and cosecant both have to have an S and a C, and so does cosine and secant. Tangent and cotangent, those are easier because they both have tangent. Okay, so we use these to relate the angles in the sides so we can find one or the other, depending what we have. So we're going to define them. If we have a coordinate plane and some point on a ray, x, y, we can drop down a straight line and we'd have a right triangle there. Okay, so this side is our x-axis, so this is length here is x, and the length to get up to our point is y. And we're going to use r to represent the length of the hypotenuse. So when we define our functions, we're going to use x, y, and r. And we always talk about our theta being the angle from the x-axis to your ray. So remember we talked about standard position, so it's like the standard position angle. Okay, so our theta will always touch the x-axis and our ray. So if you remember back from geometry, sine was defined as the opposite side over the hypotenuse, and it is still defined the same, but we're going to write it as y over r because it's the opposite in the hypotenuse. Do you remember what cosine was defined as? Very good. Cosine is the adjacent side over the hypotenuse. So that would be x over r. What about tangent? Tangent is the opposite over the adjacent, so y over x. So for the reciprocal functions, it's just that. It's the reciprocal of that. So if sine is y over r, then that means that cosecant would be r over y, or the hypotenuse over the opposite side. And the same thing for secant and cotangent. We just have to flip them. That's why it's important if you that you remember which ones go together, because all you really have to find is sine, cosine, and tangent, and then you just flip them over to get the other three functions. So do you remember the acronym or mnemonic to remember the ratios for sine, cosine, and tangent? It was SOHCAHTOA. So sine is the opposite over the hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so let's try some examples. Okay, so we're actually going to start at the one in the middle because those other ones involve some other stuff. So let's look at this one first. So it says that the terminal side, so that's where like the ray is, passes through the point -3, -4. So we're going to draw this picture like what we have here, but we're going to make it go through that ordered pair. So which quadrant would our diagram end up in? Very good. We'll be in quadrant 4. Remember, if they're both negative, the quadrant 4, we kind of reviewed that last class. So 1, 2, 3, 1, 2, 3. So here's my point. It's kind of more of a rough sketch. We just have to remember that we're always going to draw a triangle and it's off of the x-axis. So our x value is -3, our y value is -4. So what could we do to find the length of the hypotenuse, or the r that we have? Good. I hope you said the Pythagorean theorem because we have a right triangle, so whenever you're missing the third side, we always can use the Pythagorean theorem. A lot of the times we use the form, well, we're going to put r, x, and y since that's what the letters we're using, but we solve it for r. So we have that r is equal to x squared plus y squared. So this would be like c, a, and b. So we just took the square root before we started because that makes it easier to simplify. So we'll plug in our values for x and y. Oops, our y is -4. And then we just have to simplify that. So I just would want you to remember that whenever you square a negative, it always turns positive. So we end up with 9 plus 16. So we get that our r is 5. That would be the length of our hypotenuse on that triangle. So from there, we can just do SOHCAHTOA, or you can use them defined as x, y, and r because you know x, y, and r. So sine is the opposite over the hypotenuse, so -4/5. Cosine is adjacent over the hypotenuse. Tangent is the opposite over the adjacent. Since they're both negative, we'll simplify and write them as positive. So what would we do to find the other three functions? Very good. We just have to reciprocal these. Flip them over. So just remember that whenever we have a negative, we always just keep it in the top. And that would be it for those. Okay, so let's take a look at this example over here. We're going to end up doing the same thing, but it's worded a little bit differently. It doesn't give us an ordered pair like we had here. It tells us that we have an equation instead. Okay, there is one little typo here that shouldn't have a y there, so get rid of that y. It should just say 6x plus 2y. So it says that our angle is defined with the terminal side on that line, 6x plus 2y. So to be able to graph this, we need to figure out kind of our triangle there. So we can solve this for y and then graph the y equals mx plus b version of it to be able to get this line to make our triangle. So go ahead and solve that equation for y. So you would end up with y is equal to -3x. We subtracted 6x and divided by 2. Okay, so we have to figure out what quadrant we're going to end up being in. So they told us that x is greater than or equal to 0. So that eliminates 2 of our quadrants. So what are our two options now? Very good. If x is greater than 0 or equal to, it's going to end up in quadrants 1 or 2. So our first, we will start at the origin when we graph this. Well, not always, but since our y-intercept is 0, we'll start there. And then we do our slope. So our slope is rise over run. So -3 over 1. So we end up right there. So since x was greater than or equal to 0 and our slope was negative, our triangle ends up being in quadrant 4. And then from there, we have that this length here was 1. And then we went down 3. And we can find the hypotenuse just like what we did over here using the Pythagorean theorem. So go ahead and pause the video, find your hypotenuse, and find all your sides. When you come back, I will show you what you should have gotten. Okay, so we got square root of 10 for the hypotenuse. So that leaves our sign to be -3 over square root of 10. But we can't leave our answer with a radical in the denominator, so make sure you rationalize the denominator. If you need help with that, you can ask Mr. Ransfeld, or you can ask me next class or a friend. I have another video posted on YouTube about how to do that too, so you can go watch that. So once you simplify, we get -3 root 10 over 10. So there's our answers for the other ones. Just one note about like cosecant and secant. When I go to flip, I don't flip this one, because if you do, you're going to end up with the radical back in the bottom, and then you'd have to rationalize the denominator all over again. So if I have a radical in the bottom, I always just end up flipping my original, because then I don't have to rationalize again, because that would be silly. Okay, so let's try some other types of examples. So for this question, it's similar to what we did for the first example, but it gives us an ordered pair that has a 0. So when we graph that, we end up with, our point is at 0, -3. So we end up on the y-axis. So do you remember what that was called? We reviewed that last class. If we're on an axis? Very good. It's a quadrantal angle. What's the angle measure there? Good. So that would be 270 degrees. So we're trying to find the sine, cosine, tangent, and all those of 270 degrees. So you can use the definition of sine, cosine, and tangent in x, y, and r to find them, because we know that x and y, we know those values, and then we can plug into the Pythagorean theorem with those values to find r. So if we do that, we end up with r being 3. And if you don't believe me, pause the video and do the math. So from there, we can just use these values in the definitions that we defined on the front to find sine, cosine, and tangent. So sine is y over 3. So sine is y over, I said 3, I meant r. Sine is y over r, or y value is -3, our r value is 3. So we get -1. And we can do the same thing for cosine, tangent, and all of the rest. So cosine is x over r, so that would be 0 over 3. Tangent is y over x, which would be -3 over 0, which is what? Can we have that? Very good. We can never have 0 in the denominator, so that makes that value undefined. And then to find the other 3, we can just flip those. So the reciprocal of -1 is -1. What's the reciprocal of 0? If we wrote it out as flipping this one, we'd get 0 in the denominator, so we'd have another undefined value. And then if we flip this one, we have 0 over -3, which is just 0. Okay, so we're going to use this idea that we have here to fill in our tables. So if you look at the table, so this is how to find the sine, cosine, tangent, all of our functions for our quadrantal angles. So if we look at the pattern that we had over here, our sine value ended up being -1, which came from here. Our cosine value was 0. And then our tangent value is our sine value over our cosine value. So that is kind of a shortcut on how to find these if you look down here. So whenever you have the ordered pair, sine is always first, and I can't believe it. Okay, JK, typo. Cosine is first, and then sine is y. Cosine is x, sine is y. Sorry. Make sure you fix that, because that's important. We use that a lot. Okay, so cosine is x, sine is y. So we can use that idea to help us solve these. So what I would do to help you is to make a sketch of points on your quadrants. Okay, and as you saw, if our point is at -3, our radius ends up being 3, and we divide and get 1 for all of those values that had values. So when you make your sketch, what I would just do is pick 1 as your ordered pair. So this would be at 1, 0 for 0 and 360. At 90, what would our ordered pair be? Very good, 0, 1. At 180, What's our ordered pair? Negative 1, 0. And then down here at 270, we have 0, negative 1. Okay, so if we're trying to find the sign of 0, we'd be at this point. So we said that the sign value is equal to the y value. So sign would be 0. So 360 is the same because we have the same ordered pair. So the sign of 0 and the sign of 360 are always going to be equivalent because they're coterminal angles. Okay, so if we move on to 90, the sign is the y value, so it would be 1. 180, sign would be 0. 270, sign would be negative 1. Okay, and if you don't believe me, you can make a chart like this, find your r value, and then look at x, y, and r. Okay, I like to use this idea of sine being y and cosine being x because it's a lot shorter. It's like a shortcut, and we use these values all the time. So to memorize them or to be able to find them quickly, this helps. So we can do the same thing for cosine. Cosine is our x value. So we can look at all of our x numbers, and those would give our values. To find tangent, we just have to divide our sine number by our cosine number, and then we'd get tangent. And then to find the other ones, we just reciprocal those. So just remember, if you reciprocal and end up with 0 in the denominator, that's going to make it undefined. Okay, so go ahead and pause the video again and try to complete your table using that handy dandy picture to help you. Okay, so this is what we should have got. If there's any questions, you can ask me in class tomorrow. I hate typos. Okay, so I want us to try the example below that says to find the 6 trig values for 630. So I would always make angles that end up being between 0 and 360. So that's my hint. So go ahead and pause and come back and we'll talk about the answer. Okay, so if we found the coterminal angle, we ended up with 270. I looked at my ordered pair, and then I found all the values from there. So let's check out the bottom examples, and we'll be finished, and then you can do your homework. So this is asking us just to tell if a ratio is going to be positive or negative. So you really have to think about what you learned about the coordinate plane and what values are positive and negative in which quadrants, which we kind of talked about last class. So this says we're in quadrant 4. So what do you know about the values in quadrant 4? Good. Our x is positive and our y value is negative. Okay. Our r, our hypotenuse, can that ever be negative? Good, it can't, because we are squaring the values, and then they always end up positive once you square them, even if they were negative to begin with, and then we take the square root. If those were negative, then we'd have an imaginary number, which we can't have that for our hypotenuse. So the hypotenuse, or the r value, is always positive. Okay, so r is positive. So if we're looking at x over r in quadrant 4, well, our x value is positive, and our y, or our r value is always positive. Oh my gosh. So positive and positive would mean that our answer for the ratio x over r is positive. So what trig function does x over r represent? Good, that represents cosine. So that means that our cosine value in quadrant 4 is always positive, which we're going to talk more about in lesson 1.4. Okay, so go ahead and try the next 2 examples. It might help you to draw a sketch and look at, what quadrant you're in and the positive and negative signs, and then go from there. Just remember that r is always positive. So go ahead and pause, and when you come back, I will talk you through the answers. Okay, so quadrant 3, x over y is going to be positive because both of those were negative. In quadrant 2, x over y is going to be negative because x is negative. Okay, good job, class. So you can complete your homework for 1.3. So when you come back from break, I'm going to check 1.1, 1.2, and 1.3, and then our quiz will be that class on 1.1 and 1.2. So if you have any questions, you can email me at the email that's on the website, Ms. Werner Math Help on Hotmail, and I can help you. Thank you. Werner out.